Hey Algebra students, welcome to lesson 17, and this is going to be a fairly simple and straightforward lesson in algebra, probably one of the easiest all year. And the reason this is an easy lesson is because you've been using the words that we talk about math with for a long time. You've probably learned these words, you've probably learned most of this lesson in the past. We talked about what words refer to addition, what words refer to subtraction, multiplication, division. And that's what we're going to be doing in this lesson. By the end of this lesson, you should be able to turn any word problem into an algebraic numerical expression. Now, before we begin, I just want to point out the one thing that makes this a little difficult is that we're doing this in algebra. So there are some things that are just a little bit harder, and that is that we're talking about unknown quantities. So we're going to learn how to talk about unknown quantities. We're also going to learn how to talk about order of operations with unknown quantities as we go through this lesson. So pay attention to those two things that might just be a little bit more difficult than how you've learned this in the past. But we're going to start simple. The first set of words we're going to be looking at talk about addition. What sorts of words do we use in math when we want to add numbers? We use words like the sum of, the total, more than, added, increased, and plus. For example, 4 added to a number means 4 plus some number, and 7 increased by a number. Now wait a second, why am I saying a number? It's because those words, a number, anytime you hear some number or a value, we're talking about a variable. A number we don't know the value of, and maybe it takes on a range of different numbers. Okay, so notice that anytime it says a number, I have a variable over here in my expression, maybe x, maybe y. Okay, so that's what's happening, 4 plus x, or x plus 4. Hey, here's the other thing about addition. Remember, addition is commutative. There's a commutative property of addition. That means it doesn't matter which order I put these in. 7 increased by a number, the language of that seems to be saying 7 plus some number. So I'm going to put the 7 first, but really it would be the same thing if I just said x plus 7, because I can add in the other order as well. Subtraction, on the other hand, is not commutative. So we have to pay a lot of attention to what is meant for which order we should put the numbers in. So subtraction and division are the two we have to be very careful to pay attention to the order that's described in the problem. The difference between 5 and a number, notice that when it says the difference of and then lists two numbers, the first number comes first in my expression. The second comes second. The difference between 5 and a number is 5 minus x. The 5 comes first because it's mentioned first. On the other hand, if I say 8 less than a number, I'm saying that I'm going to decrease a number by 8. And that means it's going to be whatever that number is minus 8 to get 8 less than. Does it make sense to make 8 less than a number? I have to take that number and subtract 8. So with subtraction, pay close attention to what the phrase says and make sure you're careful copying down what the phrase says. Our subtraction words are less, minus, decreased by, difference, and less than. And you always have to pay attention to what is being said. What do you expect that happens? Is the number going to be decreased? Which number is going to be decreased? And if there's a number that's going to be decreased, that number should be mentioned first and then minus the other value. Now we go to another commutative one. Multiplication is commutative, so order does not matter with multiplication. We don't have to worry so much about putting these in the right order, even if there's an order implied by the language. The product of a number and 12 probably means x times 12. But it doesn't matter if I say 12 times x because it's commutative. It's the same thing. Another thing I should point out here, notice they wrote 12 and then x in parentheses. But then the next one is a number times 3. It's 3 and then x in parentheses. Again, there I would have written x times 3 with x first if I was writing down exactly what was said. 3x is the cleaner algebraic way to write that by writing the coefficient first. Okay, so that's the cleaner way to do it. And it doesn't matter because it's commutative. I could do it in either order and it would be fine. And then just notice that this 3x doesn't have parentheses around the x. That's fine too, because multiplication is associative as well. So it doesn't matter if I keep the x by itself in parentheses or if I get rid of those parentheses. it's going to give me the same result either way. Division, though, is not commutative, so we have to pay attention to order again. The quotient of a number and 6 is just like the difference of 5 and a number. The quotient, when we say the quotient, we list the first number first and the second number second. In this case, the variable is first. A number goes first as x divided by 6. However, if we say 10 divided by a number, the order gets flipped. You can kind of picture what's being stated there. We're taking 10 and dividing it by a number, 10 over x. All right, there's one more phrase you need to pay attention to, and that's related to grouping. When we have grouping symbols, we need to use language carefully to describe the grouping symbols that we're dealing with, okay? The way that we're going to do that, and here, let me bring this out to the front so that we can see it here. So I'm just going to move it over on the page. So the way that we deal with grouping is we say the words the quantity. So if it's 6 plus 7 divided by 2, if I just wrote the words 6 plus 7 divided by 2, it's unclear whether I mean 6 plus 7 first and then divided by 2, or if I mean 6 plus 7 divided by 2. So I need to have a way of saying that the 6 and the 7 go together. And that's why I use the words the quantity. It's the quantity 6 plus 7. Okay, so that means that 6 plus 7 is together. And then I take that quantity divided by 2. So whatever comes after the operation that's obviously there, the quantity 6 plus 7, there's obviously an operation happening that's going to be in parentheses, and then the next operation comes after that operation is finished, divided by 2. That's how we do grouping in words. All right, let's take a look at some practice problems and see how we can do with this. I think you're going to find this lesson superbly easy. All right, letter A. The product of x and 8 is going to be 8 times x. In algebra, we just write 8x. I could have written x times 8 as well, but I like to put my coefficient first. That's the proper way to write that. 18 minus y. Okay, so this one I have to be careful because subtraction minus is not commutative. But what's meant here is exactly what the order that's being said. 18, the minus sign, 18 minus y. All right, letter C. 7 more than 5 times x. Here, there is no wording for grouping, so I'm just going to assume that this is being done in the order of operations. So the quantity 7 more than 5 times x, that would be, if it was stated that way, it'd be 7 plus 5 first in parentheses times x. But that's not what I have going on. It's just 7 more than 5 times x. I have to do 5 times x first. So this is going to be 5x plus 7. That's how I would write 7 more than 5 times x. Letter D, Raquel is 2 years older than Monica, who is x years old. Write the expression that shows Raquel's age. Well, it's going to be x plus 2. 2 years older. Older implies more years, so x plus 2. Letter E, use words to write each algebraic expression. Now, if you're asked to do these, I suggest you use the language that's the most direct. 10 divided by s could also be written as, let's see, how else could we write this? Well, if I wanted to, I could say the quotient of a number, and let's see, the quotient of a number and 10 would be, let me think about that for a second, the quotient of 10 and a number, because I'd have to list 10 first for it to appear first in the problem. The quotient of 10 and a number would be the correct way to say that. That's confusing though, because I have to change the order. If I have to write words, I'm just going to be very direct. 10 divided by s gives me exactly what I'm looking for. There's no question what I mean by that. Letter F is going to be 5 minus r. And again, I could say the difference between 5 and r, but then what comes first? There's a question, what comes first? 5 minus r is very clear. All right, letter G. 3 times m plus 7. I could also say 7 more than 3 times m. Letter H is 3/4 times x plus 9. Now, in this one, how do I know that x plus 9 isn't grouped? Because I don't say 3/4 times the quantity x plus 9. I just say 3/4 times x plus 9. When it's written this way, I have to do things in order of operations order. So 3/4 times x comes first because it's a multiplication, and then plus 9 comes second. And lastly, letter I, last of the non-word problems. In letter I, x minus 3 over 2. Now, if I say x minus 3 divided by 2, that sounds like 3 divided by 2 is going to happen first. So this is one of those cases where x minus 3 is grouped on top, and it's not the first thing you would do according to order operations. So what I need to write here is the quantity x minus 3 divided by 2. And that gives, then it's clear. I mean, we add x, we subtract 3 from x first, and then divide by 2. All right, letter J. John has D dollars in a savings account. He withdraws X dollars each week for 15 weeks. Write an algebraic expression to represent the amount of money left in the savings account at the end of 15 weeks. Okay, so X dollars per week for 15 weeks is going to be 15 times X. This is going to be D minus 15 times X. My original amount of dollars minus the number of weeks times the amount of money I withdraw each week. And that's how you do these types of problems. Did that seem hard? There's a few kind of tricky things here, but I don't think there's anything that's actually hard. You should be able to do numbers 1 through 30 for next time.